In this video, we will discuss about some properties of inverse trigonometric functions. The first one, cosec inverse x equal to sin inverse 1 upon x for every x belongs to r minus -1 to 1. Sec inverse x equal to cos inverse 1 upon x for every x belongs to r minus -1 to 1. Cot inverse x equal to tan inverse 1 upon x for every x belongs to r. This is the category number A. Now, some more properties. Sin inverse x plus cos inverse x equal to pi by 2. Property number 1. Tan inverse x plus cot inverse x equal to pi by 2. Sec inverse x plus cosec inverse x equal to pi by 2. Now some more property, category number C. Sin inverse x plus sin inverse y equal to sin inverse x under root 1 minus y square plus y under root 1 minus x square. Sin inverse x minus sin inverse y equal to sin inverse x square root of 1 minus y square minus y square root of 1 minus x square. Cos inverse x plus cos inverse y equal to cos inverse xy minus square root of 1 minus x square 1 minus y square, and cos inverse x minus cos inverse y equal to cos inverse xy plus square root of 1 minus x square 1 minus y square. So these are some properties which can be used in our problems. Cosec inverse x equal to sin inverse 1 upon x. Sec inverse x equal to cos inverse 1 upon x. Cot inverse x equal to tan inverse 1 upon x. Similarly, sin inverse x plus cos inverse x equal to pi by 2. Tan inverse x plus cot inverse x equal to pi by 2. Sec inverse x plus cosec inverse x equal to pi by 2. There are four identities. Sin inverse x plus sin inverse y equal to sin inverse x under root 1 minus y square plus y under root 1 minus x square. Sin inverse x minus sin inverse y equal to sin inverse x under root 1 minus y square minus y under root 1 minus x square. Cos inverse x plus cos inverse y equal to cos inverse xy minus under root 1 minus x square under root 1 minus y square. Cos inverse x minus cos inverse y equal to cos inverse xy plus under root 1 minus x square under root 1 minus y square. Tan inverse, now two more, tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy, x positive, y positive, and xy less than 1. Tan inverse x plus tan inverse y equal to tan inverse x minus y upon 1 plus xy. There are two more properties for the inverse trigonometric function. One more identity related to tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy for every x greater than 0, y greater than 0 and xy greater than 1. These all the identities are can be proved. I am taking one question based on this type of identity. So you may remember whenever we use this type of identity. For example, evaluate tan inverse 1 plus tan inverse 2 plus tan inverse 3. We have the identity tan inverse 1 plus tan inverse 2. So here x and y both are positive and product of x and y is greater than to 1. So we use there tan inverse x plus tan inverse y equal to pi plus tan inverse x plus y 1 minus xy. So here tan inverse 1 plus tan inverse 2 take together and tan inverse 3 is outside the. Now applying this identity, according to this identity, pi plus tan inverse 1 plus 2 upon 1 minus 1 into 2 plus tan inverse 3. Pi plus tan inverse x plus y upon 1 minus xy. This can be expressed pi plus tan inverse 3 upon minus 1 plus tan inverse 3. Pi plus tan inverse minus 3 plus tan inverse 3. This equal to pi minus tan inverse 3 plus tan inverse 3, because tan inverse minus x equal to minus tan inverse x. Now we have pi. So if we do not remember this identity, so we can mistake the solving of this type of question. So please remember this. Whenever x and y both are positive and the product of x y is greater than to 1, so we use this identity of this type of question. Now we are taking some conversion identity. Suppose that sin inverse x, any problem is given the format of sin inverse x, and we want to convert in any other 5 different trigonometric ratio. So sin inverse x can be written as cos inverse under root 1 minus x square equal to tan inverse x upon under root 1 minus x square equal to cot inverse under root 1 minus x square upon x equal to cosec inverse 1 upon x equal to sec inverse 1 upon. So this sin inverse x converted into these 5 trigonometric ratios. So what is the process? How can we convert this? Suppose that sin inverse x is given. So sin is the identity. Sin is the trigonometric ratio in the format of perpendicular upon hypotenuse. So using Pythagoras, we have under root 1 minus x square. We start with sin inverse x. So sin inverse x bend means perpendicular upon hypotenuse. So now we take cos inverse. So cos inverse equal to base upon hypotenuse, that means along under root 1 minus x square. Now we take tan inverse x upon under root 1 minus x square equal to cot inverse base upon perpendicular equal to cos inverse hypotenuse upon perpendicular sec inverse hypotenuse upon base. Similarly, suppose we want to convert cos inverse x. So sin inverse under root 1 minus x square, tan inverse under root 1 minus x square upon x, cot inverse x upon under root 1 minus x square, sec inverse 1 upon x, cosec inverse 1 upon under root 1 minus x square. Suppose that here we start with, again we make a new figure for the inverse trigonometric ratio cos inverse x. So this is x, that means base upon hypotenuse So this become under root of 1 minus x square. Now we take sine inverse. Perpendicular upon hypotenuse, tan perpendicular upon base, cot inverse, base upon perpendicular, sec inverse, hypotenuse upon base, cosec inverse, hypotenuse upon perpendicular. So this is the way by which we can convert the inverse trigonometric ratios into the another trigonometric ratios. Suppose that we want to convert tan inverse x. So tan inverse x. How can we do this? Here make a figure for tan. This is x, this is 1, so this becomes under root of 1 plus x square. So now tan inverse x can be converted into sin inverse x upon under root 1 plus x square, cos inverse base upon hypotenuse, that means 1 upon under root 1 plus x square, cot inverse 1 upon x, sec inverse under root 1 plus x square equal to cosec inverse. This is hypotenuse upon under root 1 plus x square upon x. So these are the ways by which we can convert one inverse trigonometric ratios into the another trigonometric ratios. Now I am taking one more question. This can be used as identity, or this question may become as a problem in your examination. The question is that prove that 3 sin inverse x equal to sin inverse 3x minus 4x cube, where minus 1 upon 2 less than equal to x less than equal to 1 upon 2. So we take the right hand side. Sin inverse 3x minus 4x cube. Put x equal to sin theta. So now this can be written as sin inverse 3 sin theta minus 4 sin cube theta. This can be written as sin inverse sin 3 theta. According to the identity, sin 3x equal to 3 sin x minus 4 sin 2x. This is the identity we have already used in class 11. So now we start with the right hand side, sin inverse 3x minus 4x cube. With the substitution, x equal to sin theta. So sin inverse 3 sin theta minus 4 sin cube theta, sin inverse sin 3 theta. This can be written as 3 theta, that means 3, and theta can be replaced by sin inverse x. But before removing this sin inverse to this sin, this is necessary to show that this value 3 theta is lying in the principal branch values. So here given here minus 1 upon 2 less than equal to x less than equal to 1 upon 2. This is given. The replace substitution is sin theta. So this is minus 1 upon 2 less than equal to sin theta less than equal to 1 upon 2. This means minus pi by 6 less than equal to theta less than equal to pi by 6, because sin theta lying between minus 1 by 2 to 1 by 2, whenever theta lying minus pi by 2 to pi by 6, we want to evaluate about the angle 3 theta, so multiply by 3 in all the ratios. So we have minus pi by 2 less than equal to 3 theta less than equal to pi by 2. That means 3 theta belong to the closed interval minus pi by 2, pi by 2. This is the principal value branch for the sine function. So 3 theta lying minus pi by 2 to pi by 2. So you are right here, 3 theta lying between closed interval minus pi by 2 to pi by 2. So this can be written 3 theta. So theta can be replaced by 3 sin inverse x. Now I am taking one more problem based on inverse trigonometric function. 3 cos inverse x equal to cos inverse 4x cube minus 3x where 1 by 2 less than equal to x less than equal to 1. So we start with right hand side here. Cos inverse 4x cube minus 3x. Substitution x equal to cos theta. Then cos inverse 4 cos cube theta minus 3 cos theta. Cos inverse, this is cos 3 theta according to identity cos 3a equal to 4 cos cube a minus 3 cos a. This can be written as 3 theta, that means 3 cos inverse x. But before it, when we want to remove cos inverse to this cos, this is necessary. This 3 theta line between the principal value branch of the cos inverse x. So here we start with 1 by 2 less than equal to x less than equal to 1. So the substitution is x equal to cos theta. So 1 upon 2 less than equal to cos theta less than equal to 1. This means 0 less than equal to theta less than equal to pi by 3, because whenever the value of cos is increased, the angle will decrease. So when angle line between 0 to pi by 2, cos theta line between 1 by 2 to 1. We want to evaluate about the angle 3 theta, so multiply by 3. So we have 0 less than equal to 3 theta less than equal to pi. That means 3 theta line the closed interval 0 to pi. So here 3 theta belongs to 0 to pi. This means 3 cos inverse can be reduced. Cos inverse 4x cube minus 3x whenever 1 upon 2 less than equal to x less than equal to 1 under the given conditions. Now I am taking one more problem. Prove that 3 tan inverse x equal to tan inverse 3x minus x cube upon 1 minus 3x square, where minus 1 upon under root 3 less than x less than 1 upon root 3. So we start with right hand side. Tan inverse 3x minus x cube upon 1 minus 3x square. Put x equal to tan theta. Generally the substitution goes to the function, inverse function corresponding, which is given outside the bracket of the, there's tan inverse is given. So generally, not compulsory, generally the substitution goes to tan theta. So now this becomes tan inverse 3 tan theta minus tan theta upon 1 minus 3 tan square. This can be written as tan inverse tan 3 theta. Here identity is tan 3a equal to 3 tan a minus tan cube a upon 1 minus 3 tan square. Now this tan inverse adjust with this tan, so we have tan 3 theta, but it is necessary that 3 theta lying between minus pi by 2 to pi by 2, and this can be written as 3 of tan inverse x. So how can we check that this 3 theta line between minus pi by 2 to pi by 2? So here minus 1 upon under root 3 less than x less than 1 upon root 3. The substitution is tan theta less than 1 upon root 3. That means minus pi by 6 less than theta less than pi by 6. When theta lies minus pi by 2 to pi by 6, then theta line between minus 1 over 2 to 1 over 2. So we want to check for 3 theta, so multiply by 3, so minus pi by 2 less than 3 theta less than pi by 2. That means 3 theta line open interval minus pi by 2 to pi by 2. So this can be replaced by the property tan inverse tan theta equal to theta if theta line to minus pi by 2 to pi by 2. So this concept we use is there. So we have checked there 3 theta line is minus pi by 2 to pi by 2. So tan inverse cancel out with, sorry, 0.10 according to this. Thank you.